All right, now on to our last section for this week, section 1.7, which is properties of real numbers. So our objectives, here we have three. So our first objective is that we want to use the commutative and associative properties. Objective 2, we want to use the identity and inverse properties. And number 3, we want to use the distributive property. With objective 1, we want to use our cumulative and associative properties. We want to first go over what these are. So the commutative property tells us that if two numbers are added or multiplied together, the order of the two numbers doesn't matter since the result will be the same. So this tells us that A plus B is the same as B plus A, and that A times B is the same as B times A. Our associative property tells us that when we add or multiply three numbers, we can group the first two terms or the last two terms, and we will get the same answer each time. So when we have in parentheses A plus B outside of our parentheses plus C, that's the same as saying A plus in parentheses B plus C. In multiplication 2, it's the same thing as saying in parentheses A times B outside of the parentheses times C is the same thing as saying A times in parentheses B times C. So basically with our commutative and our associative properties, they're just telling us that if we were to rearrange whatever expression that we have, that we'll get the same answer if we rearrange them in certain ways. So that's all that these two properties are really telling us. One just deals with the order and the other deals with our parentheses or grouping certain values here. So thinking of these properties, we can go on to our examples. So example 1, we want to use the properties above to complete each statement and identify which property we used. So in part A, if we have -3 times 8, we have parentheses around each number here, so we know it's not going to be the associative property because we don't have parentheses around multiple numbers, is equal to blank times -3. Well, really the only other number that we could fill in for this spot to make this statement true is 8. So if we switch the order of -3 and 8, that's the same as using our commutative property of multiplication, since we say that A times B is the same thing as B times A. So we used the commutative property. Commutative. Then for part B, we have -7 plus, now in parentheses, 1 plus 3 is equal to, in parentheses, -7 plus blank, outside of parentheses, plus 3. So we see here is that we do have three terms, and in our first expression, our 1 plus 3 is grouped, but in our second expression, we have -7 plus blank is grouped. So we want to fill in this blank and identify our property. So if we had -7 plus 1 plus 3 in parentheses, if we were to fill in our blank here, the only number that would make the statement true would be 1. So now we have grouped -7 plus 1 inside parentheses plus 3. So since we had three terms and we changed our grouping, so we changed our parentheses from our last two terms to our first two terms, this is using our associative property. C, associative property. So our main points here is that with our commutative property, we saw the order changed. And with our associative property, we saw our parentheses changed. So these are some key things to look for whenever we are trying to identify what properties that we are using. You can also combine properties as well, so you can use both commutative and associative properties in specific questions if it is presented to you. There can be multiple. So objective 3, we want to use the identity and the inverse properties. So the identity property says that the sum of 0 and any number equals that number, as well as the product of 1 and any number also equals that number. So our identity property is saying that if we take any number and we add it to 0, we're still going to have that number. So we have an addition portion. And then we have that any number times 1 is still going to be that number. And that would be our multiplication portion. So we would call 0 in addition the additive identity, since we still get our original number if we add 0. And 1 in multiplication will be the multiplicative identity. So to put these together, we see our identity properties here. If we have a plus 0 is equal to a, and 0 plus a is equal to a, that would be our addition. And then a times 1 is equal to a, and 1 times a is equal to a. So we see here with our identity property, all we're stating is that there are some numbers in addition and multiplication that when we multiply or add by any number, our answer is still going to be that number. Then our inverse property of addition and multiplication lead to the additive and multiplicative identities. So if we're saying that they lead to additive and multiplicative identities, we know that the additive identity was 0 and the multiplicative identity was 1. So if we recall that negative a is the additive inverse of a, and 1 over a is the multiplicative inverse of a. So we have multiplicative inverse of a, sorry. So with our inverse properties, this means that if we have a plus our additive inverse, we have a plus negative a, and that's going to be equal to 0. Then we have negative a plus positive a is equal to 0. So we're adding our inverse here, our additive inverses. And then we want to multiply by our multiplicative inverse. So a times 1 over a is equal to 1, and 1 over a times a is also equal to 1. And remember, this is again when a is not equal to 0. So with our identity property, we're saying that adding 0 or multiplying by 1 gives us our same answer, and our inverse property is telling us that if we're adding, we want our answer to be equal to 0, and if we're multiplying, we want our answer to be 1. So using these properties, in our next example, we want to use the properties above to complete your statement and identify which property was used. So for part A, we have blank times 5 over 2 is equal to 1. So we have 1 here as our multiplicative identity. So we want to know what numbers can we multiply by 5 divided by 2 to equal 1. And we want to use our multiplicative inverse. And our multiplicative inverse, remember, is the same as saying our reciprocal. And our reciprocal is just that number but flipped. So we would switch our numerator and our denominator, and that would be our reciprocal. So the only number in this case that would make the statement true would be if we had 2 in our numerator and 5 in our denominator. And this is not a fraction bar. Remember, this is just saying whatever number it belongs here. So this would make our statement true. And we can check this statement. Because if we multiply 2/5 by 5/2, we would get 2 times 5 divided by 5 times 2, which is equal to 10 divided by 10, which we know from the property of 1 is just equal to 1. So we know that this statement is true. And in this case, since we had to find the number that led us to equal 1, we're using our inverse property. This here is our inverse property. And now for part B, we have negative 100,000, put in that comma there. Negative 100,000 plus blank is equal to negative 100,000. Well, if we started with one number and then we added some number and we got the same number, that first number, as our answer, we know that the only number that would make this statement true would be 0. So if we added 0 to a number and we got that final number, this means we're using our identity property. So when identifying which property that you're going to be using here, the key things that we want to look for are when we're dealing with our inverse property, is that it equals 0 for addition, or 1 for multiplication. And when we're dealing with our identity property, whatever expression we have equals the same number. So we're looking for these answers that we get, whether they're going to be 0 or 1, or if they're going to be that same number. So that's how we can identify really those differences between our inverse property and our identity property. So our last property for objective 3 is using the distributive property. So the distributive property is the only property that involves addition and multiplication. So each one of our properties we saw before, they kind of have different things that we had to kind of deal with when we had addition and multiplication. You know, with addition, with the identity property, we add 0, we multiply by 1 for multiplication. So we see there are these differences between addition and multiplication, but our distributive property combines these. So with this property, a product can be changed into a sum or a difference. The distributive property tells us that multiplying a number a by a sum of two numbers, b plus c, gives us the same result as multiplying a by b and a by c and adding them, or adding those two products. So with our distributive property here, we see that we have a times, and in parentheses, b plus c, is the same thing as saying a times b plus a times c. And we see we get these little arrows right here. So we can draw these out to kind of help us identify what we're distributing. We also have that we can put upper in parentheses b plus c first and have a at the end. And we do the same thing. We still distribute the same way. And with our parentheses b plus c times a, it's the same thing as saying b times a plus c times a. So the a outside the parentheses is distributed over the b and c inside. The distributive property is valid for multiplication, also over subtraction. So if we have a times b minus c, that's the same thing as well as saying a times b minus a times c. And if we had b minus c, all times a, is the same thing as saying b times a minus c times a. So we see here that we can use our distributive property with an addition and subtraction with combination of multiplication. So let's put some of this into practice. So for example 3, we want to just use the distributive property to rewrite our expressions. So in part A, we have 4 times x minus 9. And now we want to distribute. So we're going to distribute this 4 times to get our first term, 4 times x. And now we're going to use that same symbol that's in the center here. So we have x minus 9. So we're still going to have minus. But now we're distributing our 4 times 9. So we take our another arrow, and we're saying 4 times 9. So this is going to become 4 times x minus 4 times 9. And now we just want to simplify. 4 times x, we can just rewrite that as 4x minus 4 times 9. And then in this case, 4 times 9 is equal to 36. So then this will be our final answer, our most simplified answer here. So we see if we do label these, if we were to label 4 as A and X as B, and 9 as C, we do end up seeing that we will have A times B minus A times C. So we do end up with this form that we looked over earlier. So on to our next problem. For part B, we have 5 times 2x plus 6y minus 11z. So now we have 3 separate terms. We're going to do the same thing. So as our first term here, we're going to take our 5 and multiply it by 2x. So our first term is 5 times 2x. Then we want to keep that same operation. So we have addition first. So we have plus, and then we want to distribute to our next number. So we're going to take our 5 times 6y. So now we have 5 times 6y. And then our next operation is subtraction. So we want to add in subtraction, and we want to distribute to that final value. So we have 5 times 11z. So we have 5 times 11z. And now we just want to simplify. So we have 5 times 2x, which is the same thing as saying 5 times 2 times x. And since we don't know what x is, we can just take 5 times 2 and multiply it by x. 5 times 2 is going to be 10x. 5 times 6 times y is going to be plus 30y. And 5 times 11 times z is going to be 55z. And that would be our answer there for B. So we can also kind of label all of our numbers here. 5 is A, 2 is B, 6 is C. And let's pick up one more number, or one more color here, say orange. And 11 is going to be D. Then we see here that we did separate these out. So we have 5 times B, then we have A times B, and then we have A times C, and then we finish off with A times D. So even if we have 3 terms, we still see the same pattern occurring. Then lastly, for part C here, we don't have a number outside of our parentheses, but we have a symbol. We have a negative symbol. If we just have a negative, this is equivalent to saying -1. Since 1 doesn't change our value, but the negative does, it is like saying -1. Or we can just leave our negative and distribute our negative. So in this case, all we're doing is we're making these numbers negative. So if we want to take negative of 9w, this is going to become negative 9w. Then if we want to take that negative, we can apply it to 2v. And we're going to end up getting minus negative 2v. And once again, we see here that if that negative sign was A, and 9w was B, and 2v was C, we did end up getting A times B minus A times C. Then we just want to simplify. So we have negative 9w minus a negative 2v. Sorry, I just caught in my throat. Since we have a minus a negative value, that just becomes addition. So we get negative 9w plus 2v, and that's our simplified expression. So that finishes up section 1.7. I'm sorry, something just caught in my throat just now. So that finishes up our section 1.7, and we will continue on with our chapter 1 next week. All right, so have a great weekend, everyone.